Hello everyone, I hope you're doing well. In this video we will see how to work with Tinkercad, and as a project we are going to work with the ambient light sensor. Okay, the ambient light sensor is also called as ALS. Okay, so it has its own advantages. If I talk about ALS, or ambient light sensor, is basically photodiodes or the photodetectors which detects the amount of light present in the environment. Okay, and if I talk about the application of this ambient light sensor, so it is basically there in your all smart devices like cell phone, tab, smart PCs, where the brightness is been controlled automatically with the help of this ALS. Okay, so let's see. I have taken one ambient light sensor here, as you can see on the screen. Okay, and I'm taking a LED also. So basically what I'll do, I'll do a program with I'm going to make a circuit with ALS with Arduino, and I'm going to control the LED. Okay, so when I put the amount of light to ALS, and we will see how the LED is reacting. Okay, this is a small project what we are going to do today. So what I'll do, I'll take a Arduino I have taken already, and I'll just rotate this Arduino in a clockwise direction so that pins will align correctly at this point. So what I'm doing, I'm just take an ALS, I'm keeping it left side of the Arduino, and LED I'm keeping it at the right side of the Arduino. Okay, I'll flip LED also, and I'll flip this ALS also. Okay, it's rotating twice. Now it's fine. So basically if I just point it towards ALS or ambient light sensor, it is having two things, one collector and one is emitter. So collector act as a cathode basically. So what I'll do is I'll connect this cathode positive terminal with the 5 volt of the LED. Okay, so what I'll do, I'll just move this little bit up somewhere here. Okay, and collector I will connect it to the 5 volt basically, and the emitter I'm going to connect to the ground. Okay, when I'm connecting this emitter, make sure you're connecting it with one resistor. Okay, so I'll take a resistor, I'll just flip this resistor. Okay, I'm connecting the resistor like this, and I'm going to connect it to the ground in this way. And another terminal, same terminal of this terminal 1 or the collector point, I'm going to connect it to the A0. Okay, after that I'll change the color of the wires as it is going to the ground, so I prefer to connect with the black color, so make it black. And this terminal, this is a 5 volt going, so I'll connect it to the red, and this one I'll just keep it green color itself. Okay, and the LED, what I'll do, this is the cathode and this is the anode. So anode I'm connecting to the pin number, let's say 2, and this one will directly go to ground. So you can choose any ground, there are 3 grounds in the Arduino. So let's say I'll connect it like this. So now the ground pin I will just convert it to the black, and this one I'll just connect it to, I'll give some random color like let's say orange. Now, so as the connection is done, what I'll do now, I'm going to I'll go to the code. Okay, so let's see how to do the code for the Arduino. Fine. So what I will do now, I'll just go to blocks and then text. Okay, continue. So as you know, if I make changes in the code, so I need to declare the global declaration area first, right? So where 2 components I'm using, LED and ALS. So they're utilizing 2 pins of Arduino, right? Except 5 volt and ground. Okay, we are not supposed to consider the 5 volt and ground, so only 2 pins has been utilized by this 2 components. One is A0 and another is pin number 2. Okay, with the name I'll just assign these pins. So I'll give int as an integer I'm going to take, and I'll just write light. Okay, LIGHT for the light, ambient light, and I'm going to connect that one to pin number After this, let's say I'm connecting this to the pin number 0. Okay, I'll just give this one, and after that I'll just press enter. I'll declare another pin like int for my LED. So I'm going to connect the LED to the pin number 2 semicolon, and these things I need to declare as so LED is going to act. LED I have written in the small form, and output, right? Same, I'll declare this pin mode. As we know, this coding is going to be a very case sensitive language, so we have to use while writing alphabets, you need to take care of it. Okay, it's a very case sensitive language, and this one is going to be a input, right? So all sensors act as an input, we know this one. And I'm going to also take a serial monitor because I want to see my value received by the sensor. Serial.begin for it, and baud rate should be 9600, let's say. And after that, what I'm going to do, I'm going to read the values. Okay, so for reading I need to declare, I'm going to store that value somewhere in the variable, right? So for that I'm giving a light light val. I'm giving a light val variable. I'm considering the light val variable, and I'm going to store the value. I'm going to read the value analog read because it's connected in the analog pin. So those who are watching the video first time, I request them to go back to my first videos. Okay, go through the video so that they will understand what is analog and what is digital pins. Okay, so 0 again, then close. After that, so what I'm doing, I'm reading the value through the help of this variable, and I'm storing this all values in the light val. And after that, I'm going to see the what is the value it is receiving. So I'm going to use serial dot print ln, because in the new line I want to produce my values, light val. So whatever the value I'm storing here in the variable, okay, the sensor value, it's reading the sensor and storing in the light val, and that value I'm going to see. Okay, and after that I'm going to do the programming for this. Okay, let's see. So what I'll do, I'll just delete this thing. Okay, and now start. Let's say, so as I'm started the simulation, I'll open the serial monitor here. As you can see, the value what I'm getting is 0. Okay, so what I'll do now, I'll just click on this sensor, I'll just move this value. You can see the value is being changed, right? As I'm putting, you can see this 2 dots, right? This is showing the absence of light, and this shows the presence of light. Okay, when I'm moving the sensors towards the presence of light, or where the more light is present, at that time you see the value is changing. Initially it was 0, and slowly it is changing to some other value. It is 0 at darker, at a dark place, and the bright place it is at, that is giving the value as 471. So this value I'm going to consider, and I'm going to put the condition. Okay, so I'll just stop simulation. So what I want to do, I just, if the value, if the light val, like GHT val, is more than, let's say, 100, at that time what we want, more than 100, we want to on the LED. So I'll write digital write, WRITE, LED high. Okay, and then I'll close the parenthesis, curly braces. And one more case I'm going to go to, if, let's say, if my light val, like GHT val, is less than 100, at that point what I want to do, I want to close the LED. So I'll write digital write LED low. Fine, close the semicolon. Fine, so this is the code done. Let's see, whenever the value become, the light val has become more than 100, the LED is going to glow automatically. Okay, and whenever the value is less than 100, in that case LED will be stopped. Fine, so let's see the simulation now. So now I'll just click on this. I'll see the value is 0 I'm getting here, right? In the serial monitor you can see the value is 0. As I'm moving to the brighter area, okay, whenever the value is becoming more than 100, at that time LED is on. Okay, isn't it very awesome? Okay, 0 1 0 off on. So light is on when the value is more than 100. I'm just taking the value, say 94, 94. I'm moving away. So whenever the value is going more than 100, at that time only the LED is on. Otherwise, if it is below, it will be off. Okay, this is how this, the brightness work with the help of ALS. I hope you like this one. Thank you for watching.